Hello and welcome back. We're going to be continuing on with what we learned in valence bond theories in response to sigma and pi bonds, and we're going to identify them in the following compound. The active ingredient in Tylenol in a host of other over-the-counter pain relievers is acetaminophen. Determine the total number of sigma and pi bonds in this molecule. Well, we know whenever you have a single bond, you have one sigma bond. So one single bond is the equivalent of one sigma bond. In the case of multiple bonds, so double bonds and triple bonds, you always have a sigma bond in both of these cases. In the case of double bonds, you also have one pi bond. In the case of a triple bond, you have two pi bonds. So with this in mind, we can go ahead and count how many single bonds we have. Once we count how many single bonds we have, we can also look at how many double bonds. We can count up how many sigma bonds we have, and then we can look into consideration of how many pi bonds we have by counting the multiple bonds present. So let's start off with determining the number of sigma bonds. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Those are only the sigma bonds corresponding to the single bonds present. Let's see if we have any double bonds, which we do. So we know for each double bond that we have, we're going to also have one sigma bond corresponding to it. So we have 12, 13, 14, 15, 16. We have a total of, in this molecule, we have 16 sigma bonds. Oops. Now let's look at how many pi bonds we have. In this case, we're going to count how many multiple bonds that we have present. So we have 1, 2, 3, 4 double bonds. We know for every double bond we have one pi bond. So for pi bonds, we have 4 pi bonds. This is how you approach questions in this manner, corresponding to how many sigma bonds and pi bonds there are in a single compound. Thank you so much, and I appreciate you watching. Have a wonderful day.